Screencast 15.6, Logarithms in pH Part 2, some quick problems. In Part 1, that's Screencast 15.5, we learned some key formulas for relating pH to hydrogen ion concentration, and the same thing for pOH. In this screencast, we're going to solve some quick problems using these formulas. We'll go from easier ones to harder ones. Okay, let's go. You may recall that the pH is simply the negative log of H+. It's the powers of hydrogen, and we always use a positive value, so we ignore the negative sign. That's why this negative shows up right here. Okay, so if the hydrogen ion concentration is 10 to the minus 4 moles per liter, the pH, how many powers of hydrogen is it? 4. Remember, we ignore the negative sign. If the H+ concentration is 0.1, is the pH, what is that? The negative log of 0.1. But isn't that 0.01? Isn't that 10 to the... 0.1 is 10 to the minus 1. So the pH is 1. You could also just plug it into your calculator. Enter negative sign, not subtract sign, log 0.1, enter, and it'll give you 1. Try it to convince yourself it's true. Or you could try to think it through like I did. 0.84. I don't know what that is. I'm just going to let the calculator enter it. Negative log of 0.84. Punch it in, and you'll find that that's about a pH of 2. It's 7.5 times 10 to the minus 2. Closer to a pH of 1. And if it's 4, that's a pretty concentrated acid solution, 4 moles per liter. Well, just plug it in again, the negative log of 4, and look what you get. You get 0.6, negative 0.6, I should say. Can pH go below 0? You betcha, for some really strong concentrations of acid, or for some of these superacids. Okay, let's do it the other way around. I'm going to give you the pH, you're going to give me the hydrogen ion concentration. And this is the formula. 10 to the negative pH equals the hydrogen ion concentration. All you got to do is plug it in. Most teachers will require proper scientific notation for these. Okay, say the pH is 7. Okay, the hydrogen ion concentration is 10 to the minus 7th moles per liter. It's the exponent. For a pH of 3, the hydrogen ion concentration must be 10 to the minus 3. This is so easy. If the pH is 3.4, the hydrogen ion concentration is 10 to the minus 3.4. That's not proper scientific notation. But if you enter it just like it is into a calculator, it should spit out 3.98 times 10 to the minus 4. If you really want to do well, do it right now and go ahead and enter it and make sure you get that number. Most common error, people enter it improperly into their calculators. pH is 12.62. Well, you'll get partial credit if you just say the hydrogen ion concentration is 10 to the minus 12.62, but if you enter it into your calculator and convert it to proper scientific notation, you'll see it's 2.4 times 10 to the minus 13th. That's how we relate pH to hydrogen ion concentration. In our final slide applying this, we'll relate everything. pH, pOH, hydrogen ion concentration, hydroxide ion concentration. Given one, you should be able to get the other 3. And that'll be the topic of the next screencast. I think it's 15.6.